Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 19, Cones and Spheres. Classwork exercise 1 and 2. Note, figures are not drawn to scale. Determine the volume for each figure below. Write an expression that shows volume in terms of area, in terms of the area of the base and the height of the figure. Explain the meaning of the expression and then use it to determine the volume of the figure. So volume equals, and the volume of a cylinder is the base, and the base does not have to be on the floor. If it is a cylinder, the top can also be considered a base. So the base is right here. It is a circle with a radius of 6 inches. So volume of a sphere, a cylinder. The volume of a cylinder is base area, capital B, times the height.
Sorry, Fritz.
So volume equals the base area times the height. Okay, well, what is the base area? Well, the base area is this circle here with the radius of 6. And the area of a circle is pi r squared. So the area of this base is pi r squared times the height. All right, so now once we've broken it down to this, now we substitute in our givens. So now we say the volume equals pi times the radius 6 squared times the height 10. Volume equals pi, 6 squared is 36, times 10 is 360. Rewrite this so that pi comes last, and the answer is 360 pi inches cubed. So the volume is 360 pi cubic inches. Okay, part B. Write an expression that shows the volume in terms of the area of the base B and the height of the figure. Explain the meaning of the expression and use it to determine the volume of the figure. Again, our base is a circle with a radius of 6. So this is our base, B. This is our B. So volume of a cone is a third of a cylinder, because what the portion that we cut out, which was here, is 2/3 of the whole volume, leaving us with 1/3 being the cone. So the volume of a cone is just a third of the cylinder, base area times height. So the volume of this cone is 1/3. The base again is a circle, so that is pi times the radius squared times the height. Substituting our givens, we get 1/3 pi. The radius is 6, so that's 6 squared times our height 10. So we're going to get volume equals 1/3 pi. 6 squared is 36 times 10 is 360. Simplifying, 1/3 just means to divide by 3. 3 goes into 3 once, 3 goes into 6 twice, so 360 divided by 3 is 120 pi inches cubed. So that is the volume of this cone. Okay, part 2A. Write an expression that shows volume in terms of the area of the base, capital B, and the height of the figure. Explain the meaning of the expression and then use it to determine the volume of the figure. So this time our base is right here, and our base is a square that is 12 by 12. So this is our base. The volume of a cube is base area times height. In this case, the base is a square, and the area of a square is the sides squared times height. Now we substitute in our givens. Our sides are 12 inches, so that'd be 12 squared times the height, which is 10. 12 squared is 144 times 10. So the volume of this cube is 1,440 inches cubed. Okay. Now I'm just going to scroll to here because I want to point something out. When we look back at these two figures, a cylinder's volume is base area, which is pi r squared, times height. For some reason, I am saying something that must sound like S-I-R-I, and my phone's responding. My apologies. Now, B is a cone. The cone was 1/3 the cylinder. Okay, now when we go over here to the next problem, we took a cube, base of 12 by 12, and this is a pyramid, 12 by 12, but a pyramid is 1/3 of the cube. So the volume of the square pyramid shown below is 400 cubic inches. What might be a reasonable guess for the volume, for the formula for the volume of the pyramid? Okay, well, reasonable guess, now knowing that a cone is 1/3 of a cylinder, then I'm thinking a square pyramid is 1/3 of a cube. So I would say the volume would equal 1/3 the base area times the height. And therefore the volume is 1/3 side squared times height. And the volume is 1/3, and the side is 12 squared times the height, 10. So volume equals. Now, you need to be careful here. PEMDAS, order of operations, says, parentheses, then exponent, then multiply. So do not multiply 1/3 by 12 and say that that is 4 squared, which is 16. You'll get the wrong answer every time. Order of operations are there for a reason. We have to deal with our exponent first. PE comes before M in PEMDAS. Exponent first, so I'm not going to multiply yet, I'm going to take care of that exponent. 12 squared is 144 times 10. So now volume equals 1/3 times 1,440. And the rule of dividing by 3, if 3 will go into a number if it will go into the sum of its digits. 1 plus 4 is 5 plus 4 is 9 plus 0 is 9. 3 goes into 9, so 3 will go into 1,440 evenly. 3 goes into 14 4 times with a remainder of 2. 3 goes into 24 8 times, and then there's that 0. So the volume is 480 inches cubed, as they said. So the guess is it's 1/3 of the cube. All right, anyway, moving along. State as many facts as you can about a cone. Well, let's see. The volume of the cone, or the base of the cone is a circle. And C, or area of the circle, the area of a circle is pi r squared. The circumference of a circle is 2 pi r, or pi d, depending on whether they gave us the length of the diameter or the length of the radius. And the volume equals the base area times the height. Okay, and don't forget, actually I did, but I got thinking about it after. Let's see if this is all one piece. It is. Let me erase it. What did I forget? You tell me. I can't hear you. Alright, 1/3 pi r squared times the height. So the area is pi r squared of the base. The circumference of the base is 2 pi r, or pi d. And the volume of the cylinder, or of the cone, is 1/3 pi r squared times height. Where this piece here is a radius. This, I can do better than that. This is a height. And this whole thing is a diameter. And might as well go one step further because we're going to get into that later in this lesson. This is called the slant height, L. So we have a height, we have the slant height L, we have the radius, we have a diameter, distance around a circumference, area of the base times 1/3 the height gives us the volume. Alrighty, so exercise 3 through 10. Here it is. What is the lateral length, slant height of the cone shown below? So let me label it. This is what they're talking about when they're asking for the slant height. I will call it L, and it's asking for the length of that. Well, as you can see, this is a right triangle, so we need the Pythagorean theorem. A squared plus B squared equals C squared. This could be A and this could be B, or this could be A and this could be B, but this absolutely positively has to be C. So I'll make A 4 and B 3. So 4 squared plus 3 squared equals L squared. 16 plus 9 equals L squared. 16 plus 9 is 25 equals L squared. The square root of 25 equals the square root of L squared. Therefore, 5 equals slant height L. What is the lateral length of the slant height? 5. Or let me rewrite it so it's L equals 5 units. Okay, number 4. Determine the exact volume of the cone shown below. So I need volume. So the first thing I do is write the formula for what I need. Volume equals, it is a cone, it is 1/3 pi r squared times the height. I know 1/3 is a number, pi is a number, h is right here, this is h. That is h. What I don't know is the radius. This distance here is r. In order for me to do this, I can't have any unknowns, or I can't solve this. I don't know what the volume is. I don't know what r is. I can only solve an equation if I only have one unknown. So I need to find r first. So off to the side here, I need to find r. That is a right triangle, and I have 2 of the 3 sides, so I can find the third. So the formula for the Pythagorean theorem is a squared plus b squared equals c squared. Put the c in first so you don't make a mistake. The c is the hypotenuse, the side opposite the right angle, always. So I'm going to put that in first so I don't make a mistake. I can call a 6 or r, it doesn't matter. I'll say 6 squared plus r squared equals 9 squared. 36 plus r squared equals 81. Subtract 36 from both sides, and I get r squared equals 45. I'm not going to find r here. I don't need to know the radius because the formula, as you can see, has r squared in it. R squared is right here. There's no need to go any further. So let's continue without going further in the Pythagorean theorem. So now I substitute in my givens. R squared is 45. H is 6. I'll easily take care of this first. 1/3 of 6, 6 divided by 3 is 2. 2 times 45 is 90. So the answer is, the volume is 90 pi units cubed. When they say exact, they mean to leave it in terms of pi. Pi is irrational. If you said 90 times 3.14 and got a decimal and rounded, that would not be exact. Whenever it says exact, always leave it in terms of pi. Number 5. What is the lateral length slant height? So let me label that. That's what we're trying to find. Let's use orange this time. So the slant height goes from the peak to the center of one of the sides of the base, which is right there. Okay? And that's going to be my L. That is a right triangle right there. As you can see, the height is 8, the base is 4, and that's my C. So all we have to do to find the slant height of this is the Pythagorean theorem. So A squared plus B squared equals C squared. A is either 8 or 4, it doesn't matter. B is the other. C has to be L. 8 squared is 64. 4 squared is 16. Equals L squared. 64 plus 16 is 80. If I take the square root of 80 and I take the square root of L squared, then I get L equals the square root of 80. It says, what is the lateral length, slant height of the pyramid shown below? And it is the square root of 80. If I simplify the square root of 80 with a factor tree, that'd be 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. And I have one pair of 2's here and another here, and 2 times 2 is 4. So L equals 4, and the leftover that doesn't have a pair is the 5. So 4 square root 5. Got my calculator here to show you that the square root of 80 is an 8.944279191, and oops, let me put that back. And then if I take 4 times the square root of 5, I get the same answer. Okay? All right, so I found out. Give an exact square root answer and an approximate answer rounded to the 10th place. So there's our approximate answer. So L is approximately 8.9. The 4 does not round the 9 up because it's less than 5, so it's 8.9. So L is approximately 8.9 inches. And this should say inches as well. So there is our approximation and our exact. Okay. Determine the volume of the square pyramid shown below. Give an exact answer using the square root. Volume equals 1/3 pi r squared times the height. The height is not labeled. The height is right there. I don't know my height. What am I doing here? It's not 1/3 pi r squared height. That's a cone. Volume is 1/3 the base area, which is a square, which is s squared times height. Sorry about that. But I still don't know my height. And I'm not told my side directly, but I kind of am. So let me point something out to you. If this is 1, then if I slide it over to here, that is 1. And since it's halfway, I make a copy, and that is 1, and that is 1, then the whole thing is 2. So my side is 2. My height, I don't know. But I have a right triangle in here. Right here. So let me draw the right triangle. Let me do it in neon green. So the right triangle's here. Try that again. Okay, there's my right triangle. So I know that's 1. I don't know the height, but I know the hypotenuse is 2. So the Pythagorean theorem says a squared plus b squared equals c squared. A is 1. B is h equals c squared, which is c is 2. So 1 squared is 1 plus h squared equals 2 squared, which is 4. Subtract 1 from both sides to get h by itself, and h squared equals 4 minus 1, or 3. If I take the square root of both sides, then h equals the square root of 3. So now I found h, so I can replace it here, and I know s is 2. So the volume equals 1/3 2 squared times the square root of 3. So the volume equals 1/3 2 squared is 4 square root 3. So I can write this as 1/3 of this would be the same as writing 4 square root 3 divided by 3 units cubed, because it's volume. And it says give an exact answer using square root, so this is my answer. Okay, what is the length of the chord of the sphere shown below? Give an exact answer using square roots. Okay, so by definition, a chord is a line segment that has both endpoints on the surface of a sphere and is in the interior of the sphere. So this chord, not a musical chord like a bunch of notes played at the same time, in this case, a chord is a segment, a line segment, and more specifically, it's a segment with the endpoints on the surface of the sphere with the segment inside the sphere. That is what the definition of a chord is. So when it says what's the length of the chord, they're asking for this orange line right here. This is a right triangle. The other thing I need to point out in this, so there's a couple of tricks here that you need to know. You need to know some facts. Well, what is that? The distance from the center of the sphere to the edge is a radius. The distance from the center of the sphere to an edge is a radius. Okay? What do we know about radii of something? Well, they're all equal. The distance from the center to the edge of the sphere anywhere is the same. So this height of this right triangle is also 11 centimeters. So if this is 11, and that's 11, and this is my hypotenuse C. So to find this chord, we use the Pythagorean theorem. A squared plus b squared equals c squared, where a is 11, b is 11, and c is my radius. Or I'm sorry, c is my chord, c. C squared. 11 squared is 121. 11 squared is 121. C squared. 121 plus 121 is 242. And when I take the square root of the left, I have to take the square root of the right. So I get C equals the square root of 242. Do a factor tree and divide by 2. And I know that this is a perfect square because I just did it the other direction. So there's my answer. C equals 11 square root 2 centimeters. Give an exact answer using the square root. So there's our answer. Now, it did not say to simplify, so if you said c equals the square root of 242 centimeters, that would also be correct. Number 8 says, what is the length of the chord of the sphere shown below? So let me label it. The chord is that. So we need the Pythagorean theorem, a squared plus b squared equals c squared. A is 4, that's our radius. And I'm not going to go into such detail as the last time. What is the length of this then? If it's also a radius, it's also 4. And equals c squared. 16 plus 16 equals c squared. 32 equals c squared. Take the square root, and c equals the square root of 32. The square root of 32 is 2 times 16, which is 4 times 4. There's my pair of 4s. C equals 4. Remainder of 2 goes in the radical. So C equals 4 square root 2 inches. So once you do a few of these, they get pretty simple. Number 9. What is the volume of the sphere shown below? Volume of a sphere is 4/3 pi times the radius cubed. Okay? So what do I need here? I don't know the volume, that's what I have to find. 4/3 is a number, pi is a number, r is the radius cubed. So the only thing I don't know is the radius. Where's the radius in this diagram? Well, it is right here. It is also right here. They're both the same length because they're both radii, and that's my radius, and that's a radius. So I need the radius to figure out what the volume is. So I need to find this missing value before I can find this. So I need to find this missing value using the Pythagorean theorem. So a squared plus b squared equals c squared. A is r squared, b is r squared, and c is my chord, which is 20 squared. So r squared plus r squared is 2r squared. 20 squared is 400. Divide both sides by 2, and I get r squared equals 200. Take the square root of both sides, and r equals the square root of 200. Well, I'll do this down here, but I have to erase it. 200's factor tree looks like this. I know 100's a perfect square, so let's just cut to the chase. It's 10 times 10. So there's my pair. And here's my leftover. Okay, so r is 10 square root 2. It says give an exact answer using a square root. So let's use this for our r. This is our r. And let me erase my... Okay, so now I'm going to substitute this in for r. So volume equals 4 thirds pi 10 square root 2 cubed. So the volume equals 4 thirds pi 10 cubed. So remember, this gets distributed to both components in here. 10 times 10 is 100 times 100. 10 is, let me do that again. 10 times 10 is 100. 100 times 10 is 1,000. So 10 cubed is 1,000. And what is the square root of 2 cubed? Well, the square root of 2 cubed means the square root of 2 times the square root of 2 times the square root of 2. The square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. So 2 cubed is 2 square root 2. I can take this 2 and multiply it by 1,000. So my volume equals 4 thirds pi. 1,000 times 2 is 2,000 square root 2. 4 times 2 is 8,000. 4 times 2,000 is 8,000. So my volume is going to equal, that looks like an R, my volume is going to equal pi times 8,000 square root, too many zeros, 8,000 square root 2 all over 3. This 3 can be under the whole thing. All right, I don't like pi first, so I would rewrite that as the volume equals 800 or 8,000 square root 2 pi all over 3 centimeters cubed. So this is the volume in terms of square root, exact in terms of pi. Number 10 says, what is the volume of the sphere shown below? Again, volume. So the first thing I do is write the formula for the volume of a sphere. 4/3 pi r cubed. Then I look at the diagram and I'm looking and I'm saying, okay, I see radii is there, but or radius is there, or radii there, but I don't see what their value is. So I will just label them so I can clarify that's what I need to find. These two lengths are equal, they're both r. That's an r, and that's an r, and I need to find those. So it's a Pythagorean theorem. A squared plus b squared equals c squared. R squared plus r squared equals 12 squared. 2r squared equals 144. Divide by 2, divide by 2. R squared equals 72. Take the square root, and r equals the square root of 72. 72 is 2 times 36. 36 is a perfect square, 6 times 6. There's my pair. So r equals 6. Remainder 2 stays under the radical. So r is 6 square root 2. Substituting that in over here, we get volume equals 4/3 pi. Substitute in the r, 6 root 2 cubed. Now let's just simplify. 6 cubed, 6 to the 3rd power, 6 times 6 times 6. 6 to the 3rd power is 216. 2 cubed, again, is right here. It's 2 square root 2. So the volume of this is 4 times 216 times 2. I'll just do that in my calculator. 4 times 216 times 2 is 1,728 square root 2 pi divided by 3. Okay? 3 goes into 17 5 times with a remainder of 2. 3 goes into 22 7 times with a remainder of 1. 3 goes into 18 6 times. Square root 2 pi millimeters cubed. So the answer is, using a square root and exact, meaning leave the square root there, leave the pi there, volume is 576 square root 2 pi millimeters cubed. Okay, that is the end of lesson 19. Review the lesson summary and go to your problem set.